In this video, I'm going to introduce the idea of an if statement. And that's a fairly big topic with a few different variations. And so in order to keep things as simple as possible and as organized as possible, I'm not going to try and bite off too much with this one. I just want to cover some of the basics, and then I can record additional videos for some of those other things that we can do with if statements. So there are really three things I want to talk about here with our introduction. The one is just the basic idea of an if statement. What is it? How do we use it? When do we use it? As part of that, we're going to need to understand what a Boolean expression is and how can we create Boolean expressions, at least on a basic level. And finally, we will look at an if-else statement, which is kind of a natural addition to an if statement. So I've created a little demo project here, and it's a bit nonsensical at the moment. If I run it, it just outputs 3 lines of code. Until now, all of our programs have executed sequentially without any variation. So every time I hit play, every time I execute my code, it's going to go to the main method and it's going to execute each line of code in order, and at the end of each statement, each method call, it's going to wait for that method to finish executing and then just move right on to the next one. And so every line of code that we have written has been executed unless we've done something funny like put it into another method that we don't call or something like that. And so what we want is the ability to say, well, sometimes we may have some lines of code that don't execute and other lines execute instead. Or maybe we just have some that we skip every once in a while for whatever reason. And so this is where the idea of an if statement comes in. An if statement allows us to determine whether or not a block of code executes. Right? Or stated a slightly different way, it gives us the ability to choose which from a selection of blocks of code will execute. So we'll see some examples of that as we go along. This little demo, the code that I'm writing, is not particularly useful at all. I really don't even care what it says. I'm just trying to show the concept. So I wish I could say I had some clever program that I was going to end up with, but this is just meant to use output to visibly show what lines are executing and what lines are not. So I'm going to start off by creating an integer here, and I'll just set it to 0. And so what we want is the ability to look at this variable, days late, and say, well, depending on how late this this fictional payment has taken place, we can determine which one or ones of these messages we print out. And again, if I just execute it now, they all print out because we're just executing every line sequentially. So an if statement gives us a structure to change that. And the basic syntax of an if statement is going to look something like that. We have the keyword if, and then we have a set of parentheses. And I understand that you don't necessarily have to follow this with a code block. If you want to execute only one line of code, you can leave off these curly braces. I am going to tell you that as a beginning programmer, you cannot convince me that there is a good reason to just not put these curly braces every single time. And you can be stubborn about it if you want, because there are certainly plenty of situations where you don't need them, but it will eventually bite you, where you run into a bug because you don't put your parentheses. So, as beginning programmers, this is the structure we're going to use. We're going to have if, the parentheses, and then a code block that follows it. And inside that code block, we can put one or more lines of code that we want to have execute. The key to the whole setup here is that we put inside of these parentheses what we call a Boolean expression. And a Boolean expression, essentially we just mean an expression that will evaluate to either true or false. We've been introduced, although we haven't used it much, we've been introduced to the idea of a Boolean variable, which is either true or false. And so a Boolean expression is a little piece of code that essentially can be expressed as either true or false. And so what we end up with is this idea that we say, well, if whatever is in these parentheses is true, then this line of code executes. Okay? If it's not true, then program execution skips to the end of that code block and resumes from there. So how do we put something in there that tells it what we want to evaluate? That's this idea of a Boolean expression. There are lots of different types of Boolean expressions we can have, and the most basic ones, and I think the ones that are most comfortable to beginners, is just our basic kind of equality, inequality, greater than, less than types of relationships. We call these relational operators. And so we might say something like days late is greater than 0. So we remember from elementary school that the alligator eats the bigger number, right? So what this is saying, it's essentially asking a question. We're saying if days late is greater than 0. Now, I didn't say this was correct, my logic here, but this is the code that I've written. So if I run my code right now, what I can see is that this line of code did not execute, because right now days late is equal to 0, and I have said if days late is greater than 0, then we'll output that. So if I change that to anything greater than 0, there's my output. Okay, and it doesn't matter how big I get, obviously. That's the nature of that type of a relational expression. Okay. Now the logic here, I would express this by saying that the logic here is flawed. It is syntactically correct. The compiler has no problem running this. It just doesn't do what I think it probably should do. What this says is if the number of days late is greater than 0, then we want to say that they've paid on time. That to me sounds kind of the opposite of what we want, right? So what we want to say is if the number of days late is equal to 0, right? And so this is the first little snag that we're going to run into. If we want to test for equality using a relational operator, it's 2 equal signs. Okay, and it's 2 equal signs to differentiate it from assignment, which is 1 equal sign, right? When we put 1 equal sign, what we're saying is that to whatever is to the left, we want to modify that, and whatever's to the right, that's the value we're going to put there. Okay, so 2 equal signs, we express it verbally as is equal to. So I would read this, if days late is equal to 0. Okay, so I'm going to run it again. It did not output my code because -1 is not equal to 0. So it evaluates that expression, and it sort of substitutes, right? It puts in a -1 there. It says if -1 is equal to 0. That comes back as false because they're not equal. So it doesn't output that. It skips down to the next line of code. If I change it to 0, there we go. So if days late is equal to 0, then we're going to say that you paid on time. Right? So that's our basic if statement. And our to do this, we're using, again, this idea of a relational operator. And the relational operators are essentially the equal sign for equality. Okay, we have greater than, we have less than, and so those pretty much match up with your math class. But there are some other important ones that we don't really have keys on our keyboard to write those symbols. If in your math class you're going to say is less than or equal to, you would draw the little less than and then you put a little line underneath it, right? I don't have that key on my keyboard. So what we do is we write it like that. So we say if days late is less than or equal to 0. Okay. We can also say, I'll put that back the way I had it, something is greater than or equal to. Okay, so that's the combination of symbols we use for greater than or equal to. And then the other one that comes up in math is not equal to, or what we would say call inequality. So in our math class, we draw an equal sign and then we put like a slash through it, right? Again, I don't have that key on my keyboard, so I'm going to use an exclamation mark. And for the moment, you can sort of visually imagine that it's kind of like the slash through the equal sign. It turns out we're going to come back to that exclamation mark, which in another context we're going to use as not, N-O-T. So, so that's going to make sense because it's going to say not equal to. But visually, if it helps you to remember it as like the equal sign with a slash through it, there you go. Okay. Now we could imagine that I can put as many if statements here as I want. If days late is, and I'll use this as a demonstration of that inequality, is not equal to 0, then we're going to say that. All right, now, because it bothers me, I'm going to fix my indenting there. So here's what's happening. We're setting that variable to 0. We're checking this Boolean expression. If days late is equal to 0, and it is, that comes back true. So we execute this line of code. Whether this executes or not, we then go on to the next line, and in my case, line 24, and it's going to say, if days late is not equal to 0, then we're going to execute that. So far, so good. Let's set that to anything other than 0, and we should be mentally sort of thinking like, okay, I know what this is going to do. It should not print out this because that Boolean expression is going to be false, but it should print out that because this Boolean expression is going to come back true. All right, and it does indeed bear out. All right, now this is actually fine as a sort of conceptually. There's nothing wrong with having multiple if statements, and in fact, sometimes that's exactly what we do want. But there is another alternative here, and that is we can add kind of a clause to our if statement, which is else. And so here's what else, the way else looks visually is like that. So now here's how this works. We're going to evaluate the Boolean expression. Okay? If the Boolean expression is true, we execute this block of code. In the event that we have chosen to specify else, which is optional, else is the programming word for otherwise. So if it's true, do this. Otherwise, do that. The whole key to an if-else statement is this Boolean expression. And what essentially, if it's true, we run the if block. If it's false, we run the else block. Under no circumstances will both of these blocks of code execute, right? It's not possible for this expression to be true and then to also be false. And likewise, it's not possible that neither of these will output, right? So this is a true kind of Boolean either or situation. We're either going to run this code or we're going to run that code, all right? And so there are times when that is appropriate. And actually this seems like a pretty good sort of start for a situation for that, because somebody has made their payment. They either paid on time or they paid late, right? So we have to output one message or the other. I'm going to make a little change here. And so what I had really wanted to set up was this idea of, well, if you paid on time, we want to say that. If we paid a little bit late, then we want to kind of warn them, hey, you paid late. If they paid really late, then we got to charge you a fee, right? So for now, one way we can, maybe I should put it this way. One way we can implement that is to have another if statement, and we can say if days late. And now we have to sort of define, if it hasn't been expressed, if it hasn't been defined already, what what constitutes so late that you get charged. And so maybe we'll say, well, if you're 31 days or more late, then you get charged a fee. So what this says is if days late is greater than 31, then we'll output that. So let's run this and see. And I'm sort of mentally running test cases here, right? I've got 4, so we paid late, but not so late that we get charged a fee. So I only want to see that message. Okay, let's pay on time and see what happens. There you go. And let's pay way late and see what happens. Okay. Now, this may or may not be exactly what we really want. It outputs both of these because remember, if I say if else, one of these two code blocks has to execute. All right. So it's really two different structures that I've got here. I've got this if else statement that just says you're late or you're not late, and then I've got a separate if statement that says, well, you're so late that you have to get charged a fee. So in upcoming videos, we will take a look at alternatives to how we can handle this, where maybe we don't want to have it say you paid late and then sort of repeat that and say, well, you paid really late, so here's your fee. Maybe we want just one message. But for our basic if else structure, that's the idea of it. For the purposes of a basic introduction to this topic, there is one other concept I need to mention very quickly, and that is with this this Boolean expression that we're evaluating to determine if our if block executes, or in the case of the one here, the if else block. A Boolean expression can also be a Boolean variable, the evaluation of a Boolean variable. So let's say that we have a variable called isLate, and we define it as Boolean, and in this case I'll set it to true. I'm going to, by the way, just comment out this extra little chunk at the end so we can focus on our if-else block here. So maybe I don't have a days late variable. I just have a variable that's Boolean. It says whether or not they paid late. So we can actually just put if is late, and it's going to look at that and say, well, it evaluates to either true or false, so that's valid. In this case, it's true, so it will execute this block of code and not the else statement, okay, not the else clause. Oops. Let's change that to false and just verify. All right. So this is very common, and it's, I suppose, worth mentioning here that something that especially beginning programmers often don't realize. Two things, I suppose. One is the weird naming that we sometimes give these Boolean variables. This is an example of part of the reason why we do that, because look at the way it reads now. We can say if is late, or if has penalty, or something like that. So that's why we often name our Booleans with the word is or has at the front of them. And then the other thing is that since it is Boolean, it is not necessary to do that. Now, Java doesn't mind. It will evaluate this just like any other relational expression and say, well, if late is equal to true, it's going to evaluate that as true or false. But this is identical to just asking, is it true? All right, and so there's no problem putting that there, and sometimes beginning programmers do because that's the way it sort of makes sense to them, and that's fine. But if you're putting a Boolean and you're just checking to see if it's true, you don't have to include that part of the clause. And I just wanted to put up on the screen this nice little chart from the textbook that just shows an overview of what all these relational operators are. So you can see kind of the math or handwritten versions of them compared to the Java versions, and it's all things that I've expressed before. But that pretty much covers the basic idea of an if statement and Boolean expressions in terms of just how to implement them syntactically. So we'll look for future videos for a little more detail on some other things we can do with them.